In this video, I'm going to talk about what a function is and also talk about function notation. So let's start by talking about function notation. So say I have an equation like y equals 3x plus 2. That's just a regular equation in slope-intercept form. Now if I wanted to write it in function notation, I would write, instead of y, I would put f of x equals 3x plus 2. So again, the way that you would read that out loud is you would say f of x. F of x equals 3x plus 2. That means that we're talking about function f. So f would be the function name. F of x equals 3x plus 2. You can also have other letters, like we could say g of x equals 2x plus 4. So we would call that function g. So g would be like the name of the function. So we have function f, function g. You can also have h of x equals 6x minus 3. And that would be called function h. And again, the way you would read this out loud is h of x. Or this one would be g of x. That's just how you say that out loud, how you read those. So let's talk about why we have function notation and how we use it. F of x equals 2x plus 9. So the reason why we write it like this is because we will sometimes plug in a number for x. So say I want to plug in 8. So then you would write it like this: f of 8 equals 2 times 8 plus 9. And then you can solve that. So we would say f of 8 equals 2 times 8 would be 16. 16 plus 9 would be 25. So f of 8 equals 25. And that's a good way to create a table where you have your x and y. So that means when x equals 8, because we replaced the x with 8, so when x equals 8, then the y would be 25. Let's say I want to find another one. Let's do f of 0. So f of 0 would be 2 times 0 plus 9. So 2 times 0 would be 0 plus 9 is 9. So that means when x is 0, then y is 9. Let's just do one more. Let's find f of 2. So now we're replacing x with 2. So f of 2 would be 2 times 2 plus 9. So 2 times 2 would be 4. 4 plus 9 is 13. So that means when x is 2, then y would be 13. So that is function notation, and that's how you use it. It's basically just telling you what the name of the function is. So this would be function f. And then it's also telling you what number you're plugging in for x. So whatever number you plug in for x, that's what you put in the parentheses. So f of 8 means you're plugging 8 in for x. Sometimes you'll have a few different functions, like f of x equals 2x plus 1, and let's have g of x equals 3x minus 4, and h of x equals 4x minus 1. And then you'll have a problem that'll say something like, find f of 2. So then we know that we're going to be using function f, and we're going to plug in 2 for x. So we would have f of 2 equals 2 times 2 plus 1. So 2 times 2 would be 4. 4 plus 1 is 5. So f of 2 equals 5. And then we might have something that says find g of 6. So then g of 6, that tells us we're going to be using function g, and we're plugging in 6 for x. So g of 6 equals 3 times 6 minus 4. So when we have 3 times 6, that would be 18. 18 minus 4 would be 14. So g of 6 equals 14. And then if we say find h of 0. So that tells us we're using function h. H of 0 means we are plugging in 0 for x. So we'll have 4 times 0 minus 1. 4 times 0 is 0, minus 1 would be negative 1. So h of 0 is negative 1. So that just tells us how we find the function name, so we know which function we're using, and then it also tells us what number we are plugging in for x. Now let's talk about what a function is. So to define a function, it is for every input, there is only one output. Meaning, if we go back to our examples up here, the inputs are the x's. So that's the number that you put into the equation. The output would be the number that you get out, which would be the y value on the graph. So if it's a function, when you put in a number for x, then you should only get one number out for y. What this looks like on a table, if we have x and y, so let's do 0, 1, 2, 3, 4, and 5, 6, 7, 8, 9. So for every input, there's only one output. Let's say I had another 4 down here. If this is a function, whenever I put in 4, I should get out 9. So there's just one number that comes out when I put in a 4. If I had something like 4 and then I got out an 8, then that would not be a function. Because every time I put in 4, I should always get out the same number. For every input, there's only one output. If you put in a number and you get out 2 different numbers, then that's not a function. You might be thinking, what does an equation look like that's not a function? Or how can you put in one number for x, but get 2 different numbers out for y? So let me show you an example of an equation that would not be a function. So I'm not going to write it in function notation because, again, it's not a function. So let's say I have an equation like y squared minus 2x equals 4x plus 16. So when we're talking about inputs and outputs, so remember, if it is a function, then when I put in a number for x, I should only get one number out for y. If it's not a function, when I put in a number for x, I'll get out 2 different numbers, 2 or more different numbers out for y. So let's say I want to put in 0 for x. So plugging 0 into this equation for x, so then I have 2 times 0 and 4 times 0. So when we multiply by 0, those will just go away because they equal 0. So then I get y squared equals 16. So to finish solving for y, I would square root both sides. Now remember, anytime you square root, you need to add a plus or minus in front of the square root. So y would equal a plus or minus, the square root of 16 is 4. So that means when I plug in 0 for x, I get both a positive 4 and I also get a negative 4. So I get two different outputs from the same input. I only plugged in one number, 0, but I got out two different numbers, 4 and negative 4. So that's why this is not a function. Now let's talk about what a function looks like on a graph. So when you have a graph, to tell if it's a function, we have something called the vertical line test. Let's start with a linear graph. So let's say I graph a line. Now, according to the vertical line test, if I draw a vertical line anywhere on this graph, so it doesn't matter where, anywhere I draw a vertical line, if it only goes through my graph once, then that is a function. So these purple lines I drew, anywhere I draw one of these lines on the graph, it's only going to cross the red line once. So if it only crosses once, then it is a function. Now let's look at an example that is not a function. So if a graph is not a function, it will not pass the vertical line test. So we could have something like this, where if I draw vertical lines on the graph, you can see that these purple lines cross the red shape not once, but twice. So if it crosses more than once, then that would not be a function. It fails the vertical line test. And that makes sense, because if we're thinking of inputs and outputs, like let's say right here, this x value is -1, then it has two different y values. Like this might be 5 and this might be -3. I'm just making these numbers up. But for one input, -1, we get two different outputs. We get 5 and -3. So that would not be a function. So that is just a quick overview of functions and function notation and how to tell if it's a function from a graph and from a table. I hope this was helpful. Please like and subscribe if you liked it, and please comment below if you still have any questions or if there are any other math topics that you would like me to cover in a future video. Thank you.